In this video, we're going to look at transformations of square root functions. A transformation occurs when we move or change the graph of a parent function, in this case the square root, by changing the equation. This is going to give us a way to draw the graph of different kinds of square root functions without having a graphing calculator, or without having to create a table, simply by looking at the changes that took place to the original parent equation or function. Here's the parent function y equals square root of x, and I've also put in some key points here in blue. Whenever you do x is 1, y is 1 because the square root of 1 is 1. Then when x is 4, y is 2, square root of 4 is 2. And then I went over 9 to the right, x, and the square root of 9, of course, is 3. So those are some key points we're going to keep in mind, along with the end point 0, 0. And then I'm going to base all of my transformations on these key points. So let's take a look at one. Here's a fairly simple transformation. We've added the number 3 outside of the square root sign. So we say that's outside of the function because the addition of 3 happens after you take the square root of x. Anytime you add or subtract on the outside of the function, that's going to cause the graph to be translated or moved up or down. So this, in this case, because it's plus, is going to be up 3. So our new end point is now going to be located right here, up 3. And then each subsequent point will also be moved up 3, like this, here, and here, and here. And then I'm going to just sketch the new graph. Notice the graph shape is the same, but it has just been moved upward 3. Had this sign right here been negative instead of positive, then the graph would have moved down 3. So adding or subtracting outside of the function shifts the graph up or down. It's a vertical translation. Now this one's different. This time we've added 3, but it's inside the function. It's underneath the square root. Whenever we add or subtract inside a function, that has the effect of moving the graph left and right. When it's plus, it moves left. Seems a little backward to what we're used to when we graph. And when it's minus, it moves to the right. So the effect here would be to take each point, starting with the end point, and moving them 3 to the left. So there is the end point moved 3 left, and the next point. And I'm just taking each point that I have now, and I'm moving it to the left 3 places from where it's currently located. When I do that and sketch in the graph, again, the shape doesn't change, it's just shifted to the left 3. And had it said minus 3 instead of plus 3, we would have moved it to the right 3. So those are transformations that happen. They're called translations. They move right and left, and they're just simply adding or subtracting numbers in different places of the equation or the function. This has a little bit different effect. This time I've put a minus sign or a negative sign in front of the square root. Again, on the outside, this has the effect of reflecting the graph over x. So all that means is that instead of going over to the right 1 and up 1, we'll now go over to the right 1 and down 1 from the end point. So the end point didn't change on this graph. So we still started at 0, 0 because it didn't translate left, right, or up or down. And so we're just drawing the exact same points, except this time they're going down instead of up on y. So we have the same shape, only it has been reflected and it goes downward instead of going upward. If we do the same thing but put the negative or minus sign inside the square root, this is going to be a reflection over y. So instead of going to the right 1 and up 1, we go to the left 1 and up 1. Still the same end point again. We go to the left 4 and up 2. We go to the left 9 and up 3. And then when we draw our graph, it goes to the left this time instead of to the right. Again, same shape, but it's been reflected over the y-axis this time. We can actually put 2 of these things together, or 3 of them in this case. Here you see an equation that has 2 added inside or underneath the square root, minus 3 on the outside, and a negative in front. So this would have the effect of moving the graph to the left 2, down 3, minus 3, and reflecting it over the x-axis because it's going to have the negative on the outside. So we first locate the end point before we try to do the reflection. So we're going to want to go left 2 and then down 3. So here's my new end point. And it's still going right. It's not reflected over y, only over x. So we're going to go right 1, but not up. We're going to go down 1. We're going to go right 4, and then we're going to go down 2. And then finally we're going to go right 9 and down 3. Something like that. And again, there's our graph. It's been reflected, meaning it's now going downward instead of upward. And it has been moved to the left 2 and down 3. One you have to be a little bit careful with is this one. When the negative is on the inside or underneath the square root, it needs to apply to everything that's underneath the square root. So I've put the rest of the equation in parentheses. Otherwise, the plus 2 is going to have a reverse effect. It would not move the direction we're expecting. You could distribute that later if you needed to get this equation the way you wanted it to look. But we want the plus 2 to still mean the same thing, and it does. It means move left 2. The minus 3 on the outside means move down 3. And the negative in front but inside is going to tell us this time to reflect over y, or make the graph go left instead of to the right. So let's find that end point again. We're going to move left 2 and down 3 as we did before. This will be my new end point. Left 2, down 3. But this time, instead of going right 1, I'm going to go left 1 and up 1 because it didn't reflect over x this time. I'm going to go left 4 and up 2. And I'm going to go left 9 from my new endpoint rather. And I'm going to go up 3. And then I'm going to draw my graph. Not very well drawn, but you get the idea here that we would go through each of these points. I think I'm going to do that again. And it's something like that. This time it is reflected over the y-axis. It opens to the left. It has been moved left 2 and down 3. We can use this idea whenever we have just a graph if we need to write the equation. When I see this equation or this graph, I know that it's the equation of a square root function because I know the shape, and then I can just locate the end point. So I can start writing this equation. I see it's opening down, so it's been reflected across x. I'll put a negative there. It's been moved left 1, 2, 3, 4, 5, and I'm just going to count all the way over to 7, I believe. And so inside the function, I want to move left 7. That means I'm going to go x plus 7. And it's also been moved up 1, 2, 3, counting up to the end point. So I'm going to put plus 3. And this equation should represent the graph that's graphed in blue and that I wrote rather easily just by basing it on my parent function. You can do that with any kind of graph that still has the same shape. Now, if you want to make the shape change, if you want to stretch out the graph, or if you want to make it flatter, then you'll need to do horizontal and vertical stretches and compressions. I did another video on that, so if you want to see that video, you need to go onto my channel and look for transformations of square roots number 2, and you'll be able to see how stretches and compressions are handled whenever you put numbers in to cause that in your square root functions. You'll find other videos on this and other topics on mymatheducation.com or on the video channel, on the YouTube channel, My Math Education. I invite you to go there and check out other topics if you'd like. I hope that if you enjoyed this video, you'll subscribe to my channel and go back and take a look at other topics that we have available. I appreciate you watching, and I hope you'll come back and see other videos that will help you with your algebra. Thanks.